Hey guys, welcome. This is our Chapter 7 review, one video for Algebra. Let us begin. Alright, we got a lot of exponential rules to go over, so let's start. We get -5 raised to the -2nd power. We can't have a negative exponent, so the first thing we gotta do is get rid of it. That negative on the outside right here, though, is not in parentheses, so no matter what, I know my answer is going to be negative. So we'll put that down here with my answer. Okay, so to get rid of the negative, this is going to become a negative. I have to flip the 5 down to the bottom, and now squared is positive. We take 5 squared, which is going to be 5 times 5. We get 1 over 25, but we still have that negative because he was not in a parentheses. If it wasn't a parentheses, then we would have been okay. Next, square root of 84. Last time I checked, square root of 84 is not a perfect square. So let's go ahead and break this down into something that hopefully is a perfect square. Or we could do something with it. Now, I don't know too many numbers that go into 84, but I do know that 2 will go into 84, so let's start there. 2, and if you divide 80 by 2, you get 40, and so that'd be 42. Let's break this down. I know 2 goes into that, and that would be 21. That becomes 3 and 7. Alright, well, as far as I'm concerned, the only thing that I can see is 2. Again, the index, this number is not there, which means it implies that there's a 2 there. And so we get to pull the 2 outside in the front. What I'm left with is actually 3 and 7, so I need to multiply them back. I can't pull them out, unfortunately, so they're stuck. So I should rewrite that. I don't want you to think that I was circling them. No, these 2 are stuck there. They can't go anywhere. So we got to actually multiply them back. So we go back to 21, and we're stuck with 21 on the inside. And there we are. 2 rad 21. If you plugged in rad 84 in your calculator, and then you did 2 times rad 21, you should get the exact same answer. Whew. Alright, we have some product rules and some power rules. The first is a power rule. The 3 is distributing to both items inside, and when a power is raised to a power, we multiply. X technically has an exponent of 1, so that's 1 times 3, so it becomes x to the 3rd power. 3 times 3 is y to the 9th power. Same thing's happening here. We need to go ahead and distribute the exponent. It's a power to a power, so this is going to be x to the 8th power and y to the 8th power. Now everything's multiplying. So now we went from the, up here was the power rule, and now we're coming down here, we're going to do the product rule. Okay? In the product rule, we're multiplying, we're going to actually add our exponents, okay? So we get 3 plus 8, that's going to give me x to the 11th power. And then we're going to go ahead and grab 9 and 8, and we'll get y to, again, we're adding to the 17th power, and we're all set. That was using the power and the product rule, and we already used the negative exponent rule. We are missing some. Ho, look at fractional exponents. Great. Alright, squared is on the outside. I could distribute it now, or I could distribute it later. I'm going to choose to distribute it later. I want to deal with what's on the inside first. There's technically a 1 on this x. So the first thing is I notice we have a quotient rule. X has the same base. We got 1 and 2, so we got to find the difference. X squared is larger, so we're actually going to end up with x to the 1st power on top. So it kind of basically broke this down into 1. We have a negative exponent, which means this needs to flip up to the top. He doesn't bring these homies with him. It's just him who's getting raised to the negative exponent. So we get y to the 1st power on top. And 4 and 3 have not changed. Now we can go ahead and square everything. When we square everything, we got to distribute the 2 to 1, 2, 3, 4 different things. So 4 squared is going to give me 16. A power to a power, that's going to be x to the 2nd power, you're multiplying. Power to a power, y to the 2nd power, you're multiplying. And then this is going to be 3 squared, which is 9. Alright, 2 more. Okay, here we have cube roots. We're looking at cube roots. What can I pull out here as far as cube roots? 3 different things. Remember, the trick is to take this number and divide it into 9. So how many times does 3 fit into 9? The answer would be 3. And how many times does 3 fit into 6? The answer would be 2. Okay? So if you use that little division rule, it works quite well. Otherwise, we could show 3 equal factors. And it's true that x to the third times x to the third times x to the third would give me x to the ninth. That would be an example of the product rule. And these are 3 equal factors, so I circle 3 of them and I get to pull 1 out. Okay? I could do the same thing with the y, but we'd have to do y squared times y squared times y squared, and we could pull those out as well. Again, faster if you just divide 3 into 9, you get 3. 3 into 6, you get 2, and you're done. Last one, fractional exponents. We didn't see a 0 exponent, but we know those go to 1. So here we are going to put this into the right form. And so we're going to actually go ahead and take the 3 is going to become the index number. And the whole thing is going to be raised to the second power. First thing we want to do is take care of this. So actually, I know this one off the top of my head, but if anything ends in 5, most likely it's divisible by 5. And it's actually 25. Think about it, 25 cents is $1.25, so 5 times 25 is 125. And then you break this down to 5 and 5 again, and we get 3 equal factors. So this becomes, right here, 5 squared, which just becomes 25. Imagine that. Alright guys, we'll see you later.